Okay, here's an interesting problem. Helen had to arrange some chairs in a fixed number of rows. She estimated that there were more than 30 but fewer than 70 chairs. If she put 8 chairs in one row, she would be 7 chairs short. If she put 7 chairs in one row, she would have 2 chairs left. And we're asked how many chairs were there. Well, the first thing I would do is actually do a sort of guess and check system. I'm going to draw a little table, and which is how I would try and solve something like this. We will look at a bar model, and that I think that could be quite interesting and might develop how you might think about a problem like this. But I think a guess and check model is probably the best approach. Now, what have we noticed? We've got a fixed number of rows, okay? And that means that whatever the answer is, whether we're putting them in rows of 8 chairs or 7 chairs, it's the same number of rows. And if she puts 8 chairs in a row, she'll be 7 chairs short. If she puts 7 chairs in a row, she will have 2 chairs left. Now, what I hope you're thinking is that this is probably going to involve the 7 and 8 times table. And in fact, that's what I'm going to do. I'm going to draw a table. So I'm going to have, let's say, 7 times table, and I'm going to have the 8 times table. I've put them quite far apart, and the reason for that will become clear soon. Okay, and I am going to do some rows for this. So hang on, let's go a bit further. I'm going to do a table. So let's say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's use some colors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't need to go further than this. I've been told that there's more than 30 but fewer than 70. I probably don't even need to put the early numbers in there, but I'm going to do it anyway. Okay, so that's going to be the 7s. Here we're going to have the 8s. Obviously, I'd be much neater if I had a proper pen and paper, and you would be neater in your books, I'm sure. Okay, so what's the 7 times table? Okay, so 7 is 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. So that's my 7 times table, 1 times 7 down through to 10 times 7. And I'm going to do my 8 times table as well. So 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. Okay. Now what? Well, what happens? So this is if I put the chairs in rows of 7, and this is what I have if I put the chairs in rows of 8. Now, if I put them in rows of 7, I'm going to have 2 chairs left. Okay, so if there was one row of 7, I would also have, let's use a different color, I would also have an additional 2 chairs. Okay, if there were 2 rows of 7, so I'd have that would be 14 chairs. I would have these 2 chairs left. So add 2, add 2, add 2. So if this happens to be the number of rows, I would have this number, add 2. Okay. Now we're told there's a fixed number of rows, but we don't know which of that is. That means that it's either, it's going to be 7. This example relates to 7 rows of 7 or 7 rows of 8, for example. Okay, so that's what happens if I've got 7. If I've got 8, I'm 7 chairs short. So I would have to take away 7. Yes, take away 7. Okay. And end up with a number as a result. Okay, so let's see. In fact, I'm going to choose another color. Okay. So 7 add 2 would be 9. I don't need to do those. I'm told that we're going to have more than 30. So I'm going to start here. 28 plus 2, that is 30. 35 add 2, we've got 37. 44, 51, 58, and 65. We don't really need to do that one, but we're here anyway. Okay, so if we put them out in rows of 7, meeting the condition that we're told here, these would be the number of chairs. And let's do the same over here. We don't need to start there. We can start here. So 40 take away 7 gives us 33. That's then 41, 49, 57, 65, and here we have 73, which we know it's not that. And actually, you've probably already seen we have 2 numbers the same. They're in the same row. This is this thing about the fixed number of rows. But actually, what we're looking for is where we have 2 numbers the same. So it's when we have 65 chairs that we meet these 2 conditions. So that must be our answer. So the answer is 65 chairs. Okay, so this is a sort of guess and check model. And yeah, just trying to do a table, trying to stay as neat as possible. You probably didn't need to put in the rows or the you could have just counted up afterwards, but trying to keep it as neat as possible is really helpful. Okay, so let's see what would happen if we were going to use a bar model, because the answers that I have given you show an interesting bar model. Let's have a look, see if I can get this to move. There we go. So if you look in the answer book, you will have seen this diagram. Now, the reason why, so we have a bar model, but the reason why I wouldn't have picked this as my first solution is because I wouldn't have known where to start, how many rows to draw. And we need to think about why have they, here they've got 9 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9. But how would they have known to draw the 9 rows? But I think it's still interesting to look at this diagram. And we need to think about, if we put out these rows of 7, here are the 2 extra chairs that we're told about. And if we think about it, here the 2 extra chairs have been distributed across 2 rows. And what that would then make is a row of 8. Okay, and here's another row of 8. Here we have the row of 8 and a row of 8. Okay, so and remember, we were told that if we did have rows of 8, so this is our 8, this is our 8s, these are our 7s. If we did have rows of 8, we would end up with 7 chairs short. Now, you see it has 7 in here, but this is where we've got the 7 chairs short. So this is 1 and this is 1. Okay, so this is 2 chairs short, 3, 4, 5, 6, 7. Okay, and this is, if you thought of it this way, so you said you realized that 2 chairs short would give you, in the 7 in a row scenario, okay, that would give you 2 rows of 8, and that means you would have the 7 short. If you distributed them across these rows, that is what would give you the 9 rows. Okay, so that's what would give you, that's how you would know that you had 9 rows. And then you could just have a look at the calculation. You know that you're dealing with 9 times 8 take away 7, or 9 times 7 add the 2. Okay, that's and I think then looking at this model does help you think about how you might approach this in another way if you got a similar question again. Okay, but I think that if you haven't had experience of drawing something like this, it would be pretty tricky to do that. And drawing it that guess and check method was also just as effective.